Hello, everyone. Welcome to lecture 14 on introductory statistics. In today's lecture, we're going to move on to chapter 6. And section 1 is about idealized normal curve. Okay, so before we do that, we want to reveal what do we mean by continuous random variable. So what is a continuous random variable? A continuous random variable is a random variable that can take any values from an interval, Okay, so it is usually some measurements. For instance, so let X be the waiting time at a bus station until the next bus comes, given that the buses run every 15 minutes without fail. Now then, this waiting time is a measure of time, right? Measure that can take any values from the interval from 0 to 15. Okay? Any value, any real value from 0 to 15. So since it can take any values from the interval, it is called a continuous random variable. Okay, so you usually have a continuous nature, right? So for continuous random variable, we are usually concerned with the event that the random variable will take a value within a particular interval. So for instance, so we are always interested in what is the probability that your waiting time is less than 5 minutes, for instance, right? You waited for less than 5 minutes. So your waiting time is between 8 and 10 minutes, right? Your waiting time is over 10 minutes. Now, anyway, so it is always going to be something, all right, an event that the waiting time is in certain interval. We're not interested in the probability that your waiting time is exactly, right, exactly 5 minutes, right? That's not of interest, okay? So what we are really asking for is the probability for this random variable to be within an interval. And this is also true for other types of continuous random variables. For instance, the pressure, right? The pressure of your car, the tire for your on your car, right? The speed, right? And the volume, all right? The length, the weight, and so on. So these are all continuous random variables. Okay. So now for continuous random variables, we want to know the probability distributions. Now, the probability distribution of a continuous random variable is governed by the so-called density curve. So what is the density curve? Now, a density curve is a curve on or above the horizontal axis with a total area of exactly 1, okay, underneath it. Okay. A density curve describes the overall pattern of a continuous distribution, right? So for instance, you can see from here, right? So this is the pattern and the overall pattern. The total area is going to be 1. Okay, the total area is going to be 1. And the area under the curve and above any range of the values is a probability that the random variable assumes a value in that range. Okay, now, as you can see, for instance, right? So from the first graph, the shaded area is between 6 and 15. So this area is 0.463. So we will see what the probability for this x to be between 6 and 15 is 0.463. Okay, so this is because what? By the density curve, we know the area under the curve inside this range, above this range, this area is the probability that x is between 6 and 15. Now, similarly, now this area, right, below the density curve, above this interval 3 to 10 is 0.7472. So therefore, the probability is 472. And similarly for the last one, right, between 6 and 10 under the curve, area is 0.257. So the probability is 0.257. All right, so that is the density curve. The area under the curve over a range gives us the probability. Okay, so now a very special type of density curve is called the normal curve. So normal curve is very common distribution, has been used in many areas. Okay, so what is a normal curve? A normal curve or bell curve is a special density curve determined by a mean and a standard deviation. Okay, denoted by what? This is normal, mean, or mu, and sigma square. Okay, sigma square. With the following properties. It is firstly bell-shaped, fading at tails. As you can see, right, it's bell-shaped, and the tails at fading. And it's symmetrical about the mean. So in the center here, that's mu. Now, when mu equals 0 and sigma is 1, therefore this one becomes what? Normal 0, square root 1, that's 1, normal 0, 1. Now, this case is called a standard normal distribution, right, denoted by Z, right, capital letter Z, has a standard normal distribution. Now, the area under the curve, okay, so for a normal distribution, under the normal curve, within -1 plus 1 standard deviation of the mean is approximately 68%. So if this is mean, this is mu minus sigma, this is mu plus sigma. So the area here is about what? 68%. Now, the within two standard deviation mean, so mu minus 2 sigma, mu plus 2 sigma, and this area is about 95%. Okay, so this is also a property of normal curve. There are families of normal curves on different choices of mu and sigma. So firstly, the mean, right? The mean controls the location of the normal curve. It can take any real values, all right? It can take any real values. See this figure on the left, all right? As you can see, the mean, with different means, the location of the normal curve will be different, right? So their standard deviation is the same, so their shape is the same. However, their location are different. Now, another thing is about their shape. Right? Standard deviation controls the shape of the normal curve. It only takes positive values. Right? Larger sigma gives the flatter normal curve, or we say the larger sigma is the flatter the normal curve is. All right, the normal curve is. Okay, so as you can see, the mean is always 0, so it's centered the same. The location is the same. It's centered at 0. Now, the different, all right, sigma is different. 1, 2, 3. Now, for this one, the larger sigma is the flatter the normal curve is. As we see, the blue curve, right? The blue curve is the flattest one. So that corresponds to the largest sigma value. So this one should be what? Sigma equals what? 3, right? And then the green one is sigma equals 2. And then finally, the red one, sigma equals 1. Okay. So now this is the family of normal curves. Now, for probabilities about normal curve, we will introduce the following ways. Now, one is using the calculator based on T83 or 84. You can check this link, a YouTube link. Now, another one is the online normal calculator. All right, this is online calculator you can use. Now, for T83 and 84, we are going to use the function normal CDF. It's a lower boundary, upper boundary, and the mean and standard deviation. So to do that, you got to firstly find the mean, standard deviation, right? So And then what? For these different types of probabilities, when x is in a finite interval, all right, so you go second district normal CDF, the lower is what? A. Here, upper is B because x is between A and B. So lower boundary is A, upper boundary is B, mean, standard deviation, and enter, right? So for a second, if you find a probability x greater than A, second, go to district, go to normal. A, well, is a lower boundary because x is greater than A, right? So A is a lower boundary. For this one, we do not have an upper boundary where x is greater than A. So we're going to just using the calculator, just use a really large number. For instance, I use here 10 to the power 99. That's huge, right? So for majority of the cases, this will work, all right? At 10 to the power 99 as the positive infinity, so mu and sigma go to enter. Now for x less than b, we're having an upper boundary as b here. Now, however, there's no lower boundary. Right, so what we're going to do is we use a really large negative number. For instance, negative 10 to the power 99. And then enter. Okay, so let's consider this example. Use TID 3 or E4 and the online calculator. Well, you can use online calculator. I'm not going to describe that. All right, to find the percentage of the data from x equal to 10 to x equal to 12.56, where x is normal with mean 10 and variance 4. What about the area above x equal to 12.56? Okay, so for this one, we are going to do firstly, well, solution, right? Now you want to firstly specify the value of mu and standard deviation. So what is mu? Now, as we know, the first entry is mu, that equals 10. Now, the second entry here is the variance. Be careful, all right? This is sigma square equals 4. So this implies that sigma equals the square root of 4 equals 2. Be careful, all right? So this notation here is the first one is mean, the second one is variance. Right? In order to use the calculator, you need to find the standard deviation. So by taking the square root of the variance, you got 2. And then you can draw the, let's just sketch the graph. All right, so I'm going to sketch here. So it's centered at what? Centered at 10, right? Centered at 10. So I want to find from 10 to 12.16, 55. So let's say that this one is here. So, okay, because it's going to be what? This area. It's going to be this area, right? So here is a 12.56. Now, how to find this area? All right, so it's a probability for my x is greater than 10, less than 12.56. So this one is going to equals what? Equals, well, using the first, right? So it's second district normal CDF, AB mu standard deviation. So it's normal CDF. All right, be careful. And 10, 12.56, mean is 10, and the standard deviation is 2. All right, so enter. You can find this value equals what? Equals 0.3997. Yeah, 0.3997. Okay, and this is how we found it, right? So then next is what about the area above x 12.56? So above x, above this 12.56, that's what, to the right of the point 12.52, the dotted area here. So in other words, we want to find the probability for x is greater than this one, right? So now in order to find that, so we can use the second one, right? Second one, x greater than a. So it's the lower boundary is a, upper boundary we use 10 to the power 99. Okay, so let's do that. Normal CDF 12.56 10 to the power 99. Okay, and then here is a 10, and this is 2. So you can find that this value equals what? Equals 0.1003. Okay, 0.1003. Now, what about you try another one? Can you find the probability for x less than 9? Okay, less than 9 is going to be 10, 9, say that is somewhere here. Okay, so 9. So it's going to be this area, right? This is 9. So this is going to be what? Normal CDF. Okay, so the lower boundary, there's no lower boundary. So we use a really large negative number, negative 10 to the power 99. And then this is 9, and this is 10, and this is 2. So you can find that this is 0.3085, okay, using the calculator. All right, so that's how we can find the probability regarding to a normal distribution using the calculator. Now, the first thing is very important. Specify the value for mean and standard deviation, right? Standard deviation. Now consider another example. Draw the normal curve and shape the required area. And here is z, right? It's a standard normal distribution. Want to find the percentage of the data from z equals 0 to 0.93. So here is between this, this, and this. Okay, so here, let's consider A. All right, so let's just draw a normal curve here. Okay, so right in the middle, this is 0 and 0.93 somewhere here. So we want to find this area, right? So how to find that? That's normal CDF 0, 0.93. Okay, so because it's standard normal, so we have mean equals 0, standard deviation equals square root of 1 equals 1. Okay, so it equals, sorry, 3 and 0 and 1. Okay, so you can just find that is point what? 202, right? 0.0202. Okay, this is our A, and then B. Okay, so similarly, you can find, draw the sketch the graph. Okay, so here is a 0, and from 0 to 2. Okay, somewhere here. Okay, 2.00. So it's going to be like this area. So this is going to be normal CDF 0 to 0, 1. And this one equals what? Point what? 0.318? No. Point, what do you get? Well, sorry. I think I made some errors here, okay? So it is what? Did I make some errors? Yes, I did. Well, yes, we're good, we're good. And then this is not 0.202, right? This is what? 0.3238. Okay, 3238. And this one is 0.477. Yes, 0.477. Okay, sorry about that. And C, okay, so it's going to be what? 0 and it's 0.3, and this is 2. So this is going to be this area. So therefore, it's normal CDF 0.93201. Right, so this one equals what? This one equals 0.1534. Okay, 0.1534. And finally, D. Okay, so you want to have this, and this is a 0 above 0.93. So this is 0.93 above this one. So it's going to be this area. So we can say that it's normal CDF 0.93, so 10 to the power 99, right? 0, 1. So we find that one equals 0.1763. Okay, so that's how, right? So we sketch the graph, shade the area, use the calculator, find these probabilities. Now, again, we need to specify the values for mu and standard deviation. Consider another example, all right? So we want to find these probabilities, okay? So here A, all right? X is this one. So what is the mean? Mean is -1. So what is the standard deviation? Standard deviation, be careful, it's square root of this 3, right? So it's just square root of 3. Okay, be careful. Sigma square equals 3. So this implies what? Sigma equals square root of 3. So for A, similarly, we can find, okay, draw the graph. Now in the center as what? -1, right? So this is negative 9.0, okay, negative, okay, and 0. 0 is somewhere here, say. All right, this is 0, 0.93 negative, and we want to find this area. Okay, so this is going to be normal CDF negative 0.93, 0, -1, square root of 3. So you can find out this one equals what? 0.202. Okay, and B, all right, so you can sketch the graph in the center. That's -1. -1 point, this one is going to be somewhere here, 1.93 to -0.5. -0.5 so it can be somewhere here. Okay, so it's going to be this area, or this area. So there's a normal CDF from -1.93, -0.5, means -1, square root of 3 is the standard deviation. So you find that one is 0.318. Okay, and C, sketch the graph. -1, there is a negative somewhere here to 2. All right, to 2. Well, it's going to be here, 2. Okay. So this is going to be this area. Okay. So it's going to be what? Normal CDF, negative 0.93 to 2.00, -1, square root of 3. So this one equals 0.442. All right, 0.442. And finally, D, okay, so is gonna be, it's -1, so this is negative 0.93 below, right? Below, that's going to be to the left, all right, to the left. So we're going to use normal CDF, negative 10 to the power 99, negative 0.93, -1, square root of 3. Okay, so this one equals what? 0.516. All right, 516. Okay, so this is another example, right? So be careful. You need to specify the values of the mean and the standard deviation first. Okay, very good. Now let's consider some applications of normal distribution. Okay, so it is a widely used distribution. So let's consider some application. For instance, suppose we measure the height of every male student enrolled at a community college. If the heights of all male students at this college are known to be normally distributed, with mean 175 centimeters and sigma 10 centimeters, let's find the percentage of male students over 180 centimeters. Okay, over 180 centimeters. So we can find this one using the following steps. One, you draw a normal curve. Okay, list the real values, real data, and z-scores for at least a plus minus 2 standard deviations. All right, so the z-score, okay, as you can see, I have this normal curve, and I have it centered at 175, and this is 165, 175 minus 10. That's 1 standard deviation below the mean, and 155, 2 standard deviations below the mean, right? Because standard deviation is 10. And similarly, 185 is 1 standard deviation above the mean, and 195 is 2 standard deviations above the mean. Now it's better to consider this. And the z-scores will be what? Here is going to be -2, -1, 0, 1, and 2. Step 2 is shade the area in question. All right, shade the area. So it's over 180 centimeters. So it is somewhere in the middle of 170 and 180. All right, and over that, so it's a shaded area here. Then we want to calculate the probability using the calculator, right? So the is simply what? Normal CDF, okay, over 180. So it's 180 to 10 to the power 99. All right. And what the mean is 175, and standard deviation is 10, right? So therefore we can find we can find this one, right? So this one is what? 0.3085. 0.3085. So, and then in step 4, we state your problem based on the information in the question. So therefore what? We have 30.85% of the male students in this college are expected to be over 180 centimeters. Okay, so this is this application, right? So what we do, all right, say we have step 1, you sketch the normal curve, list the real data and the z-score for at least plus minus 2 standard deviations, like what we have here. And then you shade the area in question, right, over 180. So over 180, and then calculate the probability, and then state your answer, right, based on the information from the question. So these are the steps, 4 steps, right? So what we just described. Now let's consider an example here. All right, suppose we measure the height of every student enrolled in this college. The standard deviation is normally distributed, or the normally distributed with mean and strength. This is the same. Find the percentage of male students over 165 centimeters. Okay, so let's just do this one together. Solution. Okay, so step 1, what do? We sketch a normal curve centered at 175, and also we want to find 165. There's 1 standard deviation below the mean, another 155, 2 standard deviations below the mean, and 185, 1 standard deviations above the mean, and 195, 2 standard deviations above the mean. So this is going to be our x value. And then we also want to find the corresponding z-score. So this is -2, 2 standard deviations below the mean, -1, 1 standard deviation below the mean. This is 0, exactly at the mean. And this is 1, 1 standard deviation above the mean. And this is 2, 2 standard deviations above the mean. So this is our step 1. And step 2, all right, let's just step 2, right? Step 2, 1 and 2. Okay, we can put 1 and 2 together. 2 is over 165. So 165 is somewhere here. Okay, so they shaded the area. So we can see that this is like this, right? So it's the area to the left, to the right of 165. Step 1 and 2. And step 3 is going to be what? Is to calculate the probability, right? So we're going to use normal CDF 165 to 10 to the power 99 and 175 and 10. Okay, so this one equals what? This one equals 0.8413. 8413. Now, step 4 is what? Step 4 is, um, is we know that the percentage is between what, 84.13% of the male students are over 165 centimeters. Okay, so this is how we solve this problem, right? So step 1, sketch the normal curve, list these values. Step 2, shade the area. Step 3, calculate the probability. Step 4, state the the answer based on the information from the question. Okay, so pretty simple, right? Now let's consider another example. Okay, consider this example. Now the setting is exactly the same, so meal, standard deviation. Now here we want to find the probability that the male students who are 180 and 190 centimeters between this, right? So similarly, steps step 1 and 2. I'm going to put them together, all right? Step 1 and 2. So I'm going to sketch this one similarly like what we just did. Okay, so let's say this is centered at 175. Say this is 165, and this is 155, and this is 185 and 195. This is my x values, and this is the z-score. 1, 0, 1, and 2. All right, step 1 and 2. Step 3, or 2, I need to shade the area in step 2, right? So 180 to 180 is somewhere here, 190 is somewhere here, so it's going to be something like this. All right, so this is the area. Now step 3 is going to be what? Normal CDF. Okay, so 180, 190, this is going to be 175, and this is 10. Okay, so this one equals what? This one equals 0.2417. Okay, and then finally, step 4. Okay, we know that 24.17% of the male students are between what, 180 centimeter and 190 centimeters, right? So similarly, we can do this. Okay, I think that's all for this one. Okay, so thank you for watching. I will see you in the next one. Bye bye.